Hello and welcome to the Walking Talking topic on graphs, question number 6 with me, Mr. Barton. Now we're going to raise the bar a little bit here because we've got our first occurrence of the word perpendicular. Select two of the following lines which are perpendicular to the straight line AB. You must give a reason for your selection. Okay, so we've got to know what perpendicular means. Perpendicular means cross at right angles. And there's something very important that you need to know about the gradient of lines that are perpendicular. And that is, if you've got a line who's got a gradient of, say, 2, then the gradient of the line perpendicular to it is minus 1 over 2. And if you've got a line that's got a gradient of, say, a third, then the gradient of the line perpendicular to it is minus 3. The pattern here is that they are the negative reciprocal of each other. And the way I like to say this to my students is that means you change the sign, so it goes from positive to negative, and you flip it upside down. So it goes from 2 to 1 over 2, or it goes from 1 over 3 to 3. So it's the negative reciprocal. You flip it over and change the sign. So if we can get the gradient of the line AB, then we can do the negative reciprocal to get the gradient of the perpendicular, and then we can go through each of these in turn to try and find two of them that have got the gradient we need. It's a really high demand question, this one, but I think we're going to be okay. Right, let's get our gradient of the line AB first. So I'm going to write this down here. Gradient of AB. Okay. Now we did gradient before, I think it was question 1 or question 2 maybe. Gradient is the change in y divided by the change in x, and we've just got to be careful of the sign. Well look, he's drawn us a beautiful right angle triangle here that we might as well use. You can draw a right angle triangle at any point on this line, so let's go for this big one here. So what's the change in y? What's the height of this right angle triangle? Well, it goes from 0 to 12, so it's got a change in y of 12. What about the base of this right angle triangle? Well, it goes from 0 to 8. That's 8. So the gradient is the change in y, 12, divided by the change in x, 8. And the only other thing we've got to remember, it's sloping downwards, it's negative. So it's going to be minus 12 over 8. Let's simplify that a little bit. Divide top and bottom by 2 maybe. I think we get 6 over 4, minus 6 over 4. And we can probably go a bit further. So if we divide by 2 again, I think we get minus 3 over 2. Or minus 1.5, whatever you prefer. So that's the gradient of AB. So let's put a little circle around that. So what's the gradient of a perpendicular? Gradient of perpendicular. Well, as I said before, we've got to find the negative reciprocal. Change the sign, flip it upside down. So it's minus 3 over 2, so when we change the sign it's going to be positive, and if we flip it upside down, we get 2 over 3. So I've now just got to hunt down equations here that have got gradients of 2/3, 2 over 3. But it's not quite that simple because some of them are in nasty forms. And to get gradients, to get it easily, I need the lines to look like this. Y equals mx plus c. And then the number in front of my x is going to be my gradient. And as soon as I find one that's 2/3, I'm good to go. So let's hunt them down in turn. This first one's not too bad. Y equals 3 over 2x. Well, that's got a gradient of 1.5. That's no good. I'll just make a note here, I'm looking for lines with gradients of positive 2/3. So that one, forget it. What about this one here? What's the gradient of that? Well, it's not easy to see like that because it's not arranged the right way. So let's rearrange it. So let's try and squeeze it on here. If I take 2x from both sides, I get 3y equals minus 2x's plus 8. So that's just taking away 2x from both sides. Now if I divide by 3, I get y equals minus 2/3 of x plus 8. Now that's almost looking good, but it's a minus 2/3. It's a negative gradient, so forget that one. That's not looking good at all. What about this one here? Now I won't try and squeeze this one. I'll just write this one down here. So I've got 2y equals 3x plus 6. Now, I've got to rearrange that to make it y equals mx plus c. So let's divide everything by 2. I get y equals 3 over 2x plus 3. Has that got a gradient of 2/3? Nope, that's got a gradient of 3 over 2. Forget that. So I'm down to my last 3 here. It's not looking good, this, at the moment. What about this one here? Y equals, so let's write this here, y equals minus 2x plus 8 over 3. Now that's almost in the form I like it. Everything's been divided by 3, so let's just separate that up. That's y equals minus 2/3 of x plus 8 over 3. Has that got a gradient of 2/3? Nope, got a gradient of minus 2/3. So forget that one. That one's gone as well. So we're down to our last two. I hope these ones work, otherwise I'm going to be in a little bit of trouble here. So let's have a look at this one. I'll just write it down here. I've got 3y equals 2x plus 5. So let's go for this one. 3y equals 2x plus 5. Okay, let's get it rearranged. So I've got to divide everything by 3 to get it into its magic form. So I get y equals 2/3 of x plus 5/3. Finally, I've got one that's got a gradient of 2/3. So that one works, and I'm going to say it's got a gradient equals 2/3. Perfect. I've just got to hope the other one works as well. So what have I got here? 2x minus 3... Sorry, I'll just show you so you've got it there. Final one. 2x minus 3y equals 8. Let's write that down here. 2x minus 3y is equal to 8. What's the gradient of this? Well, we've got to rearrange it. Now, this is a flipping nasty rearrangement here. I've got a negative 3y's here. So what I'll do is I'm actually going to get my 3y's over to this positive side. So I'm going to add 3y's to both sides. So I end up with 2x there, and I get equals, and I've got my positive 3y over here, and I've still got a positive 8 over there. Now I'm going to take 8 off both sides. So I end up with 2x take 8 is equal to 3y's. And finally, I'm going to divide both sides by 3. So I end up with 2 over 3 x's minus 8 over 3 is equal to y. So y is equal to 2/3 of x minus 8 over 3, following a nasty rearrangement. And that's looking good as well, because look what I've got there, a gradient of 2/3. So I also there have a gradient that is equal to 2/3. So I've got my two perpendicular lines, and they were the final two. Now that is extreme straight line graphs. Well done if you managed to follow that one.